Which of the following is the correct Lewis structure for CO or carbon monoxide? So let's start by actually drawing the two atoms, right? We have carbon and oxygen. So how many electrons does carbon have in its valence shell? Well, it's in group 4, so carbon is going to have 4 electrons that it brings. And then oxygen, well, it's in group 6, so it's going to have 6 electrons, so for a total of 10 electrons that we're going to need to have. And then also we need to make sure that each of them has 8 valence electrons in its outer shell when they're sharing the electrons, right? So we need to draw up, obviously, at least one bond connecting them, because they're in a molecule. And then let's give these two atoms the rest of their electrons to start with, right? We're going to give oxygen its electrons to make it have its octet. And then also, and by the way, these would be like the 6 valence electrons that it brings, right? And then carbon, we'll give it 2 electrons here. Because now carbon, if you notice here, we have 2 electrons, and then we have 2 electrons in the bond, and then we have 6 electrons here. So that's going to be 10 electrons. That accounts for all of them. So what do we actually do now? Well, what we need to do is we need to make sure both atoms actually have a full octet. Right now, oxygen does have a full octet because it has the 2 shared electrons and then the 3 lone pairs. But what about carbon? Carbon only has actually 4 electrons in its outer shell, which is not what we need. So what we can do is we can actually bring this lone pair in to form a bond, and then this lone pair, okay? And so what we're going to get then is that these lone pairs are still on the carbon. There's 3 bonds between them. Then there's oxygen, okay? And oxygen has these 2 lone pairs. So if we look, carbon has, the 3 bonds, so that's 6 electrons, and then 2 electrons lone pair, that's 8. And then the same thing with oxygen. But what about the formal charges? Well, let's calculate, right? So carbon here, remember the formula, it has 4 valence electrons minus the number of non-bonding electrons, which is 2, minus 1/2, okay, the number of bonding electrons, which is 6. Okay, so that's going to be 4, minus 2, which is 2, minus 6 divided by 2, which is 3, so that's going to be minus 1. So here, carbon actually has a minus 1 formal charge. What about oxygen? Well, oxygen normally has 6 valence electrons. You subtract the non-bonding ones to the lone pair 2, minus 1/2, 6, okay? And so that's going to be 6, minus 2, which is 4, minus 6 divided by 2, which is 3, so that's going to be plus 1. So oxygen here has a plus 1 formal charge, okay? So therefore, let's look at the answer choices, right? A, C triple bond with both atoms having a full octet, okay, that's wrong. B, C double bond O, so that's wrong right away. And then C, C triple bond O with a lone pair on both atoms, -1 formal charge on carbon and +1 on oxygen, that is our answer. And of course, D is wrong as well. Now, one way that you could approach this also, if you, had forgotten how to do, how to assign everything, is you can just go through the answer choices, as long as you know how to assign formal charges, and try them out, right? And make sure that both atoms have a full octet, right? And so the only one where that's actually going to work in this situation, right, is C. So C would have to be the right answer.